So I'm back working on that Crown DC300 again as the parts have arrived from China. And I'll let you in on a little secret. There's more wrong with it than the op amp. The op amp, yes, bad. Replace the op amp, one channel works, the other channel still has a problem. Parts have arrived for the Crown DC300, so as I take this thing apart to replace the IC and get it working, I figured I'd have a little discussion again regarding shipping, because this seems to be shipping things in to be repaired. This seems to be an ongoing problem, maybe some confusion. See, I get people that ship stuff in and they put a high dollar declared value on a broken piece of equipment, and that triggers taxes that have to be paid by the shipper, by the way, because I won't pick it up until they're paid for. In one case, it's adding $120 right there to the cost of repairing an item that may not even be repairable. I don't know because I haven't seen it. But anyway, so there's been a bit of comments from people saying, well, you have to declare shipping and they won't ship it unless you put a declared value on it. Carriers won't accept it. Well, that's not exactly true. Or if you don't put the actual declared value on it, if it gets lost in shipping, you're out the money. Well, you're not really out the money because what you're sending is broken. So it really has zero value because it's not a functional piece of equipment. And saying parts value, well, they're really not worth that much. People that advertise stuff for sale for parts are living a pipe dream because most people are not going to pay anywhere near what people are asking for parts for any of this stuff. The only time I've ever had anything lost in transit was about a year and a half ago now. That's around, I think it was Christmas 2020. A fellow shipped a DAT machine. I forget the model, but it was a Sony DAT, I know that. And when he contacted me, I told him, I said, it's got to be shipped to my P.O. box. And when he took it to the post office, some bonehead at the post office told him that, oh, shipping to P.O. boxes is not safe and it's likely to go missing. We don't recommend you ship to a P.O. box. You're better to ship it to the address and use something other than USPS. Use another carrier. So the guy went and somehow found out my address. Google's a wonderful thing for privacy invasion as far as I'm concerned. And anyway, he proceeded to ship it to my home address. Of course, I'm not even aware of this. I'm expecting it to go to my P.O. box. Several days later, I get an email from the fella asking what the status is, and I said, status? I haven't received it. I haven't received notification from the post office, and then he informed me that he shipped it to my house. And well, I looked at he told me the date that it arrived, and I went and I looked up my security cameras and found that, sure enough, FedEx delivered it and dropped it at my door, and a few minutes later a guy walks up dressed in black, got a hoodie on and face mask, picks the unit up casually, tucks it under his arm, and off he goes. 3 weeks later, I got a bill. Between 2 and 3 weeks later, I get a bill from FedEx for, I think it was $72 in broker charges and taxes because it had a declared value placed on it of, I think it was $200. So there was $200 US was converted to Canadian, and then 12% tax was added, and then the broker fee, of course, which is $37.50. The person that shipped it made a claim and got their insurance, I'm sure, but it didn't end there because FedEx kept hounding me for the broker fees and taxes that they had paid, which I told them where to go and how to get there. about as many words. The next thing that happens is I'm getting calls, and I'm still getting calls to this day from collection agency because I basically told them to F off. And this is the problem. That's the only thing that's ever been lost. I could have lost a SLV R1000 that was left at my door, and that was the one I made the video on called Screw You Canada Post, because that was somebody else that looked up my address and shipped it to my address rather than my P.O. box. For whatever reason, I don't know. But that one, I just happened to come home for lunch literally within 10 minutes of it being dropped off, and I was able to put that one in the house safely. But it could have just as easily been stolen. The thing is, nothing else has ever gone missing, and it shouldn't. Not in today's postal system. If you ship something with a tracking number, which I'm sure most people do, any person that touches that package from the time it leaves your hand until the time it's delivered has to scan it, and it's on them. So every truck that it gets loaded on, it's scanned. If it gets put on an airplane, it's scanned when it goes on the airplane, it's scanned when it comes off the airplane, it's scanned when it goes through customs. How do I know that? Well, my sister was a customs agent for 30 years, and she worked in the package mail delivery for a while there. She worked at the Canada Post station where all packages were brought in. So that's how I know. You know, everything's scanned, everything's accounted, so nothing's going to go missing. And it's not just sent to a P.O. box. It's out in the middle of nowhere where somebody can break into it and steal it. It's at a manned facility. And when I go to pick something up, I have to prove who I am. Now, to tell you how good the security is, I have to show a government-issued piece of identification, my driver's license. It has to have my address that's registered with my P.O. box listed, and it must be the original document. During COVID there, when we all had to have our vaccine passports to get into restaurants, I got tired of having to pull my driver's license out every time I wanted to go in and get something to eat. So I took a picture of my driver's license on my phone so that I could show my little QR code that they would scan at the restaurant, and then I could just swipe over and here's my ID, there's my picture, and you're good to go. That was not good enough to sign out packages. They would not accept that. I had to actually produce the document. So things that are shipped in, nothing's going missing if it's shipped by tracked mail. And it's shipped with no declared value of over $20, or preferably the box is checked where it's repair or return, which means it's going in for repair and then it's being returned. Then there's no questions asked. If things come in with a high declared value, you are going to pay the tax. Whoever's shipping me something, you're going to pay the tax, not me. And for those that are dumb enough to send it by FedEx and it doesn't get stolen, I will double the cost that FedEx charges me just for my inconvenience of having to deal with FedEx. Although I don't think FedEx is going to be delivering anything to me, because in my books I'm a bad boy. I have very bad credit with FedEx because I've still got an outstanding debt with them that's going on over a year now. So I don't think FedEx is going to be too happy with me. Anyway, let's get the IC changed. I tell you, it's funny, earlier today I was going to the local hardware store to get some wall anchors for a tower rack that I had to fix. It got knocked off a wall, so I've been spent last week or so fixing the wall. I had to patch it and plaster it and let it dry and put another coat on and stuff. So it's taken me a week or so of working on it to get it fixed. I'm going up there and I found that someone had a little oops. They looks like somebody stepped on the gas instead of the brake and kind of totaled two vehicles. So I sent a message to my wife, and this is what I sent to her, and look at her reply. Typical, right? I said, my accomplishment for the day, and it's about time. Like, the drywall mud is just barely dried and sanded. I catch hell for it not being fixed fast enough, I tell you. So here's the new IC. I'm going to pop it in place of this other dead one. I got a couple of them shipped to me just in case one's bad, but you never know, right, with parts these days. So many counterfeits floating around that you never know whether you're getting a genuine part or getting a fake one. But this is just a little off amplifier, so these are pretty common. It's also a Fairchild part, but that doesn't mean anything. It still could be a fake. Okay, pin 1 is in the top corner here. Whoops, you can see the marking on here, the little dot to indicate that that's pin number 1. This is a socketed IC, which is always nice. It's easy to take socketed ICs out. Just pop it out and pop the new one in place. And then we will check and see whether we've got a working amplifier or not. It's so sticky out today. It's so hot. Another hot one. It's like almost 30 degrees in the shop today, and everything I lean my arm on sticks to me. It's just one of those muggy, sticky days. I know some people say, it's 30 degrees, it's nothing. It's a lot hotter here in Australia. Yeah, but your heat is a dry heat. It's a lot hotter up in the interior too, where it's a dry heat. Here it's like 90% humidity hit this temperature. It's ridiculous. So it feels a lot hotter than it actually is. And air conditioning is running full tilt to keep the house a nice chilly, I don't know, I think I've got it set to like 24 maybe Celsius, 23, maybe 23, I forget. I'm going to check for any DC voltage. Oh, for Christ's sake. Stay put. Alright, now where's my speaker terminals on here? This one, I think that's the speaker terminal. I can measure right here on this resistor. See if there's any. I got my dim bulb tester. No DC voltage! Yes! There we go. We have our where's our power? Where the heck is the power going in on this stupid thing? We should have voltage there, 58 volts. And this other one here should have, here's my negative supply. Negative 58. And my speaker output is 0.86. And this one over here we have, we got voltage on this side. So one side's working and one side's not. Well, that's interesting. Why is that? Might be a balance control that's out of whack on one of them. But this side's got no offset. That's good. But this side here has 58 volt, 57 volts. So we fixed one side because we had DC voltage on both sides before. Get our plus and minus voltages here. Where's my positive voltages of that one? There we go. So the IC is working. Is it plugged in all the way? Let's just check the schematic. This has got balance controls on it. So maybe one of the balance controls got knocked out of whack. Offset. One of these variable resistors is the offset. And it will affect DC on the output if it's out of adjustment. So let's just put our meter on the output here. And we'll just try adjusting a balance control and see whether we can balance this thing down. One of these is the balance control. Oh, we got no DC on one channel, which is good. If we look, this is the balance control here, and this one on this side. Because I can adjust this one here. You see I've got 0.1 volts DC, and I can adjust this. Balance it down so that there's no DC. This will affect the DC offset. Ideally you want it at 0. But this other side, we still have a DC voltage on this side, so there may be a problem still. Well, there is a problem still on this side. Because my balance control is having 0 effect. Either that or this IC is no good, one of the two. But I doubt that's the issue. I think we probably still have a shorted transistor or something else that's shorted on this channel that may have been the cause. Although we lost the Zener shorted before, right? So we had no negative voltage. That's why we had why we had a high DC voltage on both sides. So it may be just a connection that's broken, or there may be another part that's bad on this channel, such as a shorted transistor or a broken connection. So if we look at the output from the IC, pin 13 is the output to drive the amplifier. As you can see, 0.14, and pin 1 is the output to drive the other side, and it's got 8 volts on it. I don't know why it's so bloody hard to find pinouts for components these days, but it's almost impossible. You get sent to all these sites that want you to install a download helper or something. You know, that's not going to happen. I'm not installing anything on my computer to look at a PDF. You know, send me the freaking PDF and let me look at it. I don't need to download your helper, which is going to be a Trojan horse of some type. It's going to be a virus. It's going to install something on my computer. It's not going to happen. Anyway, our inputs for this one. We know the B side is okay because we looked at that. Like, you know, pin number 13, for example, had no voltage on it, but pin number 1 did. That's the output from this left channel. The input pins is the positive and the negative input pins are 5 and 6, because pin 7 is the negative supply. So 5 and 6. Let's just see whether there's any DC going into the IC itself. So here's pin 5. There's 1 volt going in there. And pin 6 has also got 2 volts on it. We look at the other channel. The other channel, the inputs are down here, the 2 bottom pins. We'll see we got 0 and we got 0. So we got voltage going in. So the problem is, before this section, the problem is on the input. We've got a voltage going in to our input pins, which is pin 5 and 6. So if we look over here, here's our input pins over here. 5 and 6, we do have a DC voltage that's going into there. And there is a resistor on there. And there's a couple diodes as well. But these are pins 5 and 6 here. We've got a bit of DC voltage. Now there is an input bias which does go up here, goes through this other trimmer, but then there's also one on the other channel, and we know that this channel is good. So if I look at the 2 variable resistors here, they're both fed from a common positive supply. If we look at them here, we'll see that we have 5 volts, and we have 0, and we have 5 volts, and we have 0. So that part is good. We're good at this point. But on the wiper, what do we got on the wiper on this one? This one here, the wiper has got 0.8 volts, which sounds pretty reasonable. What does this one have? Where's the wiper? I can't see it. This down there? 2 volts. There are 2 volts on the wiper there, but this one here doesn't. Will it adjust? Okay, we'll bring this up to 2 volts. Now, does that take away my bias? Still got 57 volts there. What do we got down here on my input pins again, which were these 2? I've still got 2 volts on one, and I've got 1.4 on the other. And as I say, if I look at the other side, I got 0 and 0. So we still got a little bit of voltage getting into this IC, which is being amplified, which is what's driving the output high on the output for the IC, which is what in turn is driving the amplifier into full conduction. So there's a resistor here. There's actually 2 resistors. The other side it's fed down here from this is from the inputs. Now there should not be any voltage on the input. That's coming off of the control over here. Let's just see first of all if there's any juice on the control. So there shouldn't be anything. It should be sitting at 0. And it is. There's nothing on the input, which is what's to be expected. Yet we've got a voltage sneaking in to the input. And that's coupled in through, there's a capacitor on here, looks like a small cap. There's a couple diodes, and it's going to this output offset control. Let's just check the voltage on that, because that could certainly cause it. If we look at the output offset, the wiper on this one is 0.9 volts. Output, 4 volts. Well, that would explain everything. Let's just see if I can tweak that. I'm just going to take my watch off because I'm sticking my hand in where there could be the circuitry, and I don't really want to become part of the circuit. So I'm sticking my hand in here to hold this probe while I try adjusting this output offset control and see whether it will bring that voltage down. Okay, 4 volts, 1 volt, 0 volts. With the offset down at 0, do I still have an offset? We still have an offset here. So what the heck? 2 volts, 1.2, and we're still going to have minus 8 volts going out the output. There's a transistor over here that's in the negative feedback. So I got the schematic in the layout here, and everything's backwards. Everything is backwards on here. So because they did a running change, or the schematic is different, the numbering is different. Like on, this is my board, my layout here, and on here they call it R206, C214, D212, D213, but on the schematic they're not. It's D113. The other side's got like a D212 and D213 over here. D113, it should be D112, but it's actually listed as D212. Everything seems to be backwards. Like R106, which is my offset resistor, off the offset control of R105, which R105 is clearly this one here. But on the schematic it's listed as R205. Like they've got the numbering reversed. I think this schematic is a different revision. Because this is the A channel, this is the B channel, so this should be the 1, this should be the 2 side of everything. But you see, it's listing serial numbers, and the serial number is not in this range. This is actually a lower, this is a lower serial number range than this. So the boards are the same, they've numbered them different, but the schematic, on the other hand, this is correct. Because when I look at the pinout, and this is a blown up version, the pinout is correct. Right, pin 5 and 6 are the inputs, and pin 8 and 9 are this channel. So this is this channel, the right channel, and this is the left channel, or the A channel. They don't call it a left and a right, they call it an A and a B. So the schematic is correct. The numbering on here is different than the number on the layout. So I got 0.1 volt on that side, and on this side I've got 2.1. This is the resistor. That's that resistor there, R106, which is what's delivering my offset over to the IC. Let's look at R101, which on this would be listed as R201. So where is that one? So that's going to be the positive offset. Right there. This one should be the positive offset. Let's just measure the voltage on that one. Let's see what we've got here. So we've got 2.7 on one side and 0 on the other. Okay. This is the one from my bias. It's a 2 meg. And this is what provides some positive voltage into going to measure the other side. So R201, let's just see what it is on the other side. It's R101 on the other side. Let's see where it is. Okay, it's right over here. R101 is to see where it is, right next to D 113 and 112. Okay, that's the resistor there. Let's just measure the voltage on this one and see what we get. 2.3 on this side, again 0. So I get the same reading as I've got on this one over here. I'm certainly getting a bad feedback, so it must be coming from something over here further in the output stage, because I've got an incorrect voltage on the input, and it doesn't appear to be coming from the balance. It must be coming back from a component over here that's bad. So our voltage is off here. I'm thinking it's feeding in from here, and it's a positive voltage, so this is the negative rail here. This transistor might be problematic right over here. This is looks like Q102. Let's find another schematic. Shows it a little bit bigger. I've blown it up, right, to make it a little easier to read. So here is the voltage is incorrect here. So we got some DC voltage here. If we trace this back, it comes up here, and this transistor here, Q102, might be problematic. Now, as I've discovered, everything's backwards on here, so Q102 will be actually Q202. If we look at the layout, you'll see that Q202 is this one right here, right next to the offset. So there's our 203. Okay, so this is it here, Q202 or Q102. Let's just do a quick in-circuit measurement and see if there's any problems with this transistor. So we'll just get the meter in the shot here. We'll just make a quick measurement here and see whether there's any. 0.095 emitter to base. How about emitter to collector? No short there. How about base to collector? That looks okay that way. Okay, base to emitter. Our base to collector looks okay, but base to emitter looks like we've got a short. Base to emitter short. Now let's look on the schematic here. We had a base to emitter short. What's it going to do for me? Now it might not be. It might be other, others. I'm looking. It could be other circuits that are loading it down, but I will definitely have to disconnect that to measure it, because I'm measuring a base to emitter short. Now there's a couple diodes in series, but that shouldn't make it show up as a short. I should see a voltage drop across them. But definitely something in here. So let's just pull this board, and I'll measure. I'll disconnect one side of that transistor so that I can measure it. You see that transistor is shorted. Okay, let's just see. We'll pull this transistor right out, and we'll measure it and see whether it's bad now out of the circuit. Or whether it's okay. No, it's not measuring bad out of circuit, so must be something else loading it. So I can throw this one back in. Check Q219 or 119, I guess it is. This is this one right down here. Let's just see whether we get anything across this one. There's a connector. Right across here. That's 6. I think there's a diode across that one though. Just look on the schematic here. There's a diode across one side of the junction. No, there's a resistor. Okay, that was Q119, which is this one right there. And there's a resistor, 180K resistor collector to base. The emitter is fed off the 10-volt supply. So if we had leakage on this one, it will pull this output from the IC high. So I'm inspecting the board, and I just happen to notice that right down here, I think that might be the problem. Kind of buggered up to me, doesn't it, to you? Let's I'm just going to look at the board and go over it, but that connection definitely is broken, and that may be our problem right there. That may have been what blew everything up in the first place, although this one, the IC was definitely popped and that Zener diode was shorted, but board's also got other problems. So I'm just going to resolder this section of the board here, and maybe that will fix my negative or my positive voltage problem. Looking at this closely with magnifiers, it certainly is apparent that there's a few connections on here that don't look that good. So I'm just going to go over a few of them, and we'll fix this one over here that was broken completely. You can see where the strip of foil was burned off before, which when I put the new Zener diode in, I bridged over it. But here's this other one right here that is bad. So we're going to solder that component down, and then I'll try this thing and see whether we got rid of that DC voltage on the left channel. And hopefully that's where the problem is. Swing this board back up and just put 1 or 2 screws in it just to hold it in place so that we don't have anything touching. And then I'll test it and see whether there's any voltage present. Let's just power this sucker up and see whether there's any voltage on this. I still got DC. Damn. I figured I'd pull the 2 non-polarized caps out and just take a look at them. One of them looks like it might have been leaking a little bit onto the board, and if you look at the top of them, even though they measure fine, if you look at the top of them, one of them looks like the heat shrink may have started to expand a bit. So I'm going to try just changing this one out. It's a non-polarized, so I'm going to have to make it up by putting in two regular caps back to back, and I mean my value won't be exactly the same, but we'll see whether that makes any difference. Let's put this other one back in place first, and I'll make up one. It's a 22, so the closest I'm going to have is probably a couple 47s, but that'll at least get me in the ballpark and see whether that makes any change. I don't think it will, but the fact that if I look at this capacitor here, it looks like it's been leaking a bit. Let's see, look around the edges there. It looks like it's been leaking. And if we look at the top, it just looks like it may have gotten a bit warm. For those that forget capacitors 101, how you make a non-polarized capacitor is you put 2 regular capacitors in series with each other with the negative terminals connected together. So the 2 positive terminals are what's going to go onto the board, and that turns it. And of course you have to double the value. So typically, if you want a 22 microfarad, you would put 2 44 microfarad in series, which of course there's no such thing as a 44 microfarad capacitor, so we got to go to the next one up, which is 47, which will increase it a little bit, but they give us like 23 and a half microfarads or so, but that's still, we're fine. Capacitors are not that accurate anyway, so as long as we're in the ballpark, we should be okay. I've been inspecting the board to see if there's been any tin whiskers, because that's certainly this is of the right era that tin whiskers could have easily formed on the board. I haven't spotted any, but that doesn't mean that there isn't any silver dendrite, as it's called, that's grown between them. I just haven't seen anything obvious. Could be on any component though. Of course, tin whiskers basically cause a dead short. It's literally metal that grows between, like a little whisker that grows between one charged lead and another, just due to a chemical reaction with the air, with oxygen. So it's caused all kinds of issues over the years, especially on things like potentiometers, old TVs, anything old. And the old stuff tends to have it affect them more than more modern stuff. That's one of the reasons they put a conformal coating on most modern electronics. They'll put a conformal coating on the board, is to try to limit the growth of tin whiskers. Okay, so I've replaced this one cap with two caps in series, and we'll see whether there was some internal leakage. Capacitor measured fine. It measured fine on ESR. It measured fine when I checked for any leakage. Didn't measure any, so, and we still have our voltage creeping up there, so we know it wasn't that, but I figured I would change it just in case, just because the fact that it looked like some electrolytic had been leaking out of the bottom of it. So a couple of new caps replaced the one that was apparently leaking, but it wasn't at fault. So we're still investigating as to what the problem is. So as I'm checking everything, I get down to this one last transistor here, because everything else is checked good. Our resistors are all testing good. The diodes are testing good. Transistor kind of looked questionable in circuit. Let me just pull that transistor out. Okay, let's check this one out. See if this transistor is any good. This is one of the pre-drivers. Already checked this other one. This other one's okay. This one here. So this is the PNP one, I think, or is it the NPN? This is the PNP driver. So the NPN one tests good. Let's check the PNP. So base will be negative. Base to emitter. Base to collector. This bastard's open. Woohoo! Transistor went. What is this value of this thing? Motorola. It's an SS7304. Let's see if I can look that up and see what it crosses to. Unfortunately, I don't have a transistor that's equivalent to this, and one that's going to have to be sourced. That could take some time because these are getting to be relatively hard to get parts for. But we'll certainly persevere and see if we can find another transistor for it. I'd love to get this thing running, and the guy that owns it, I'm sure, would love to have it. I don't know that he's going to want to pay what it's going to cost him to have it done because of the amount of time that's been spent chasing down faulty parts. But we'll certainly see if we can dig up a transistor. I'll do some research on it, and we will pick this up in a part 3 at a future date. Thanks for watching.